Okay, so I'm just going to take a look back at what we did previously at the start of the log section. Now, if we look at this, okay, now remember that logs are inverses of exponentials. So instead of y equals 2 to the x, remember I've swapped the x and the y around, remember that from the inverse section? So if I graph this, remember before, it ends up looking like this, again, based on this table, okay? And that's what we did previously. Now, if you remember, the exponential graph looks like this, okay? And in the inverse section, we talked about inverses, okay, as a reflection over the y equals x line. So this is the y equals x line. And so this is, if I try and do this, just art, not math, there you go. And of course, that is what the log graph looks like, okay? Again, if you look at this. So again, the log graph is the inverse of the exponential graph, okay? If I flip it over the y equals x line. Right, let's have a look at some. So here it is. Here is the log to base 2 of x. And if you remember, I said that this is the same as, if the base is 2, then this is the log to base 2 of x graph. Okay, so if we're going to graph it, then here is the table. Now then, this is a little more difficult because we don't have a log to base 2 button on our calculator. We have a log to base 10 button. But I can pick numbers I know I can do. So if I do this, if I put x equals to 1, okay, log to base 2 of 1, okay. Well, if you remember, if you log 1, you always get 0. And the reason is this, remember, okay, 2 to what exponent will give me 1. Okay, if I rearrange it from the log to the exponential form, well, that is, of course, 0, okay? And that is that point right there. 1, 0, which is on every log graph, because when you log a 1, you get 0, okay? Okay, so how about when x is 2? The reason why I did it, I'll just erase this, is because I can kind of do that in my head without a calculator. Log to base 2 of 2, what does that equal? Well, remember, here we go. 2 to the power what will give me 2, and that is 1, okay? So again, that's that point there. And so on. I'm going to pick a 4 there. And the reason is log, let's erase that and do it back up here, okay? So, log to base 2 of 4. Now, I can't do log to base 2 of 3. I won't pick 3, okay? I'm going to pick 4 for x. I'm not going to pick 3 because, again, I can't do it. I don't know what. 2 to the power what gives me 3? I know 2 to the power 2 gives me 4, okay? And again, that's what that point is. And finally, if I just choose an 8, okay? And the reason why I'm choosing an 8 is, okay, and not anything else between 4 and 8 is because I know that's 3, because 2 to the power 3 will give me 8, okay? And again, that's that point there. When x is 8, y is 3. Now, you can also look further down here at some harder ones. Oops. And I can say to myself, right, log to base 2. Okay, when x is a half, why did I pick a half? The reason is it's negative 1. And its reason is this is because 2 to the negative 1 is 1 over, remember this? Flip it, 1 over 2 to the positive 1, which is a half. Okay, can't write a 1, there you go. Okay. And again, so there it is. So when x is a half, about there, y is negative 1. So again, this is what it looks like, log to base 2 of x. This is the kind of basic look of every log graph. Doesn't matter too much what the base is, okay, but it'll definitely look something like this. And if I go back to the previous slide, remember, here it is, okay? There it is. Right, so if I look at some other ones. Now, here we go. Log to base 4. Now again, don't worry too much about base right now. It's a log base. Now remember your transformations. It's been moved 3 to the left. Okay? So, here we go. If I'm going to draw a log graph, don't worry about the base 4. Remember that if we look at this here, the y-axis, or x equals 0, is a vertical asymptote. The graph gets nearer and nearer to that line but doesn't touch it. The domain of these graphs are 0 to infinity, okay? Again, with a parenthesis because I can't include. I don't touch the 0 line, okay? That's the domain. Can you see the range of these are negative infinity to positive infinity, okay? So the domain and the range, okay? Again, because you can see the range is going up and down forever. But again, definitely the domain Starts at 0, goes on to infinity. Doesn't include the 0. So, now then, if I just said to you that the vertical asymptote was the y-axis, if I move it 3 to the left, I'm going to draw another vertical asymptote, okay, there at x equals -3. Okay, now remember, this point, I'm going to erase it a bit, but this point here, it said is on every log graph. If I move it 3 to the left, it's now going to become there. Okay, let's just erase that. Okay, so all I really need is an approximation, and it's something like this. There we go. If I just do that, that is fine. You've just moved the log graph 3 to the left. Now, I could do something like this. Have a look at this, okay? Now, if I was being really smart, I could do this. Watch this. Log to base 4. If I write x equal to 1, and I'm not picking this randomly, if I say when x is 1, what's the answer? Can you see that's 4? Okay? Log to base 4 of 4, remember, is 1, because 4 to the power 1 equals 4. Now then, so it is that when x is 1, y is also 1. So can you see that is pretty horrible because I'm supposed to hit that point there. So if I just do it again, okay, I'll get to there and say to myself, right, okay, so there, that's a little bit better, okay, and that's just me kind of throwing some extra credit there, using a bit of kind of previous experience, realizing that if x is 1, y is going to be 1, okay, and again I won't pick any other number. If I picked x equals 2, I'd have a 5 here, wouldn't I? And I can't log to base 4 of 5. Right, now then, how about this one down here? This just means move it 2 to the right. So for here, I would just, again, get that new vertical asymptote, 2 to the right instead of the y-axis. And again, remember, I would put a point, oh, if it's 2 to the, remember, this point is now here. Okay, remember, the 1, 0 point is going to there. And again, I would just do something like this. Something like this is fine, okay, because I moved it 2 to the right. Now this one here, if you remember your transformations, negative in front is just an x-axis reflection, So all I'm going to do is, instead of this, I'll put this as a dotted, instead of that, I am going to do this. There you go, folks, there you go, an upside down log graph because of the minus in front. Oh, I should go back to these and say, think about this. What's the domain of this? The domain of this is 2 to infinity. The domain of this one here, what's that? That's -3 to infinity. Can you see that? Again, because of the vertical asymptote. I have one more slide, I think. Right, finally, this one, all it means is go up 5. Now, sometimes you'll see them written back to front in a sense, because if I write log to base x, base 2 of x plus 5, which kind of what we would normally do, we just want to make sure we haven't confused it with that one, because of course that is to the left 5. I want up 5. Okay, now then, if I'm moving up 5, this means I am not changing the vertical asymptote, but that stays exactly where it is. It's only a left and right movement that will change the vertical asymptote. Okay, so if I go up 5, remember at this point that is usually at 1, 0, is now going to be here because it went up 5. There's going to be a point there because it went up 5, okay? And so on and so on. Really, again, approximately something like that. The domain hasn't changed, it's still 0 to infinity. The range hasn't changed, it's still negative infinity. Okay, but all I've done is move it up or down, really. Okay, so no left or right movement, so no change to the domain or the vertical asymptote.